Okay, our next topic is the intensity or loudness of sound waves. Quiet sound waves don't carry as much energy as louder sound waves. And what this relates to is that the particles, it depends on how compressed they are and how spaced they are. When we talked about compressions and rarefactions, in a very loud sound, the particles would be very compressed during the compression and then very spaced out during the rarefaction. So if you could see, for example, the particles in the air when you heard a loud sound, if you could see the air particles, you would see a great amount of compression and then a great amount of rarefaction where the particles are really spaced out, and then another great compression. Quieter sounds have less compression, less extreme difference between the compression and rarefaction. Um, Now, intensity is the word that we use to describe that amount of energy. Okay, intense sounds have more energy. And this influences how far away a sound can be heard. Very intense sounds can be heard for a long distance. And the word that we usually use in everyday language to describe intensity is loudness. So loudness is the human perception of sound intensity. And we measure loudness in a scale uh, in units called bells, and that's named after Alexander Graham Bell, the inventor of the telephone. And a bell, the unit that we actually use is tenths of a bell or decibels. Okay, so that's how we measure how loud a sound is. And what we have over here on the right is a chart of sounds from moderate, very loud, extremely loud, and painful. And it also lists the danger zones of where you get hearing loss. Just to get some reference points, normal conversation is roughly in the neighborhood of 60 decibels. Uh, chainsaws, loud lawnmowers, things like that are probably, the high 90 decibels. And beyond that, very loud equipment, jackhammers, things like that are getting above 100 decibels. Um, and one thing that's important to understand is that the decibel scale is not a linear, it's not a straight line scale. Uh, so relatively small changes in the number of decibels, you may perceive them as very big differences. For example, a 90 decibel sound and a 96 decibel sound. 6 decibels doesn't seem like it would be that much, but your actual perception of that would be that a 96 decibel sound would seem to you to be about twice as loud as a 90 decibel sound. So small changes in the number of decibels uh, can make a big difference in how we perceive sound and how uncomfortable we sound it. You should also pay attention to um, the zones where you run into hearing loss. I have some hearing loss myself. I'll talk about it a little bit more on a subsequent slide. But my hearing loss comes from when I was your age, back in the 1970s. I used to work on a farm in a packing house. It's like a factory, and of course back then there were no laws to protect your hearing. It was a very loud environment, and I would work there at parts of the year. Sometimes during the year, I'd be there every day for very long hours. I also rode a lot of motorcycles back then, and exhaust systems of motorcycles were much more primitive back then. They were much louder than they are today. Uh, and I also played electric guitar in bands. So the three of those things, the working in that factory type of environment, the motorcycles, and the loud music, probably all contributed to the hearing loss that I have today. It is something that you want to pay attention to. Today we have laws that protect you in the work environment, and car exhaust and motorcycle exhaust. Machines are much quieter now than they used to be, but still you need to protect your hearing. Okay, now the next slide is about frequency of sound. Okay, and frequency refers to how fast sound waves are vibrating. We perceive changes in frequency as changes in pitch. So, for example, I'm seated at a piano here, and if this piano, if I play the note C, okay, then I can go up a scale. Okay, so what you're hearing is a change in pitch. The loudness isn't really changing, but the pitch is changing, or the frequency of the sound is changing. This is an electronic piano, so it also has one of these finger rolls. If you can change the pitch with the roll button. I'm not sure exactly what you call it. Okay. Now, the range of human hearing is generally given at 20 hertz, or 20 cycles per second, 20 vibrations per second, up to 20 kilohertz, or 20,000 vibrations per second. So that's the general range of human hearing, but this varies a lot among people. Women typically can hear higher frequencies than men. And it also varies between species quite a bit. As the last point on this side of the PowerPoint says, this range is exceeded by many other species: dogs, bats, elephants, rodents. In fact, almost all other animals hear a wider range of frequencies than we do. Dogs can hear much higher sounds. Bats, rodents, they all make sounds and can hear sounds that we can't even hear ourselves. But our hearing is particularly good in that 20 to 20,000 hertz range. It probably has a lot to do with our speech communication and the evolutionary history of speech communication. Okay.